Hello everyone, I'm Ian Rodriguez from the Grootsters, and today we're going to be talking about transforming rational functions. Okay, so before we start translating our rational functions, let's take a look at the parent function. So our parent function is y is equal to 1 over x, this one right here. So the parent function is the base for all our rational functions, and you can use the formula f of x is equal to a over x minus h plus k, or f of x is equal to p of x over q of x. You can use these formulas in order to get a good idea of how the functions are translated. Okay, so when plugging in certain points into a table, we can find how the function looks like. So looking at the parent function and plugging in carefully selected values for the x coordinates, we can get our y coordinates. So -2, -0.5, -1, -1, 0, undefined, we'll explain that later, 1, 1, and 2, and 0.5. Okay, so once these points are all plotted out, it'll look like this. 1, 1, 2, 0.5, -1, 1, -2, -0.5. So those are just a few points, but once you add a few more, it'll look like that, and it'll make a whole graph. It's continuous, and it kind of looks like two boomerangs or an hourglass. So that's what a parent function looks like. Okay, so now let's look at the key characteristics of the parent function. The domain is all real numbers except 0. The range is all real numbers except 0 as well. For the behavior, as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches 0. For the asymptotes, the vertical asymptote is 0, the horizontal asymptote is 0. Both the x and y intercepts do not exist. Okay, so some might be wondering how to find the inverse of the parent function. And the inverse of the parent function is actually y is equal to 1 over x, the same thing. So basically, how do we find it? So when you find the inverse for any function, you switch the x and y values right here. And you basically simplify, and it turns out it's going to be the same thing, still the same. And same as the parent function is going to have the same points. Same in the table, and there we go. For the inverse function, it's pretty much the same thing as the parent function. So the domain, all real numbers except 0, range, all real numbers except 0. For the behavior, as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches 0. For the asymptotes, both the vertical and horizontal asymptotes are 0, and both the x and y intercepts do not exist. Okay, so now we're going to translate the function by changing the c and d values. So, what will the new function look like? Taking a look at the formula, we are going to see that the parent function will move 3 units left and 4 units down. Okay, and by changing up different points in the x values, we will get these points. And once you connect it all together, you'll get this. Okay, so for the translations of the c and d values, the domain is all real numbers except -1. The range is all real numbers except 0. For the behavior, as x approaches infinity, g of x approaches 0. As x approaches negative infinity, g of x approaches infinity. For the asymptotes, the vertical asymptote is x is equal to -1. The horizontal asymptotes, y is equal to 0. For the x and y intercepts, x-intercept is 1, 0, and the y-intercept is none.